Hello, and thank you for joining us today for the React track of our JavaScript marathon training session. Our trainer today is Brecht de Rooms, Senior Developer Advocate at Fauna, and he is joining us today from Belgium. You can find him on Twitter using the handle at the bottom of the screen, and please don't hesitate to get in touch with him if you have any questions, feedback, or concerns from anything that you see or hear in the training session today. And we couldn't do this without our sponsors. Our first sponsor today is This.Labs, your partners in modern digital transformation. We specialize in mentorship, consulting, training, and staff augmentation for enterprise organizations. You can find out more at this.labs.com or send us an email at hi@this.co. Our next sponsor today is FaunaDB, the database built for serverless featuring native GraphQL. Add a full-featured global data store to your apps in minutes. Access effortlessly from the browser and from mobile, and never again worry about data correctness, capacity, redundancy, latency, and availability. Today, they're offering you a generous free tier, so try FaunaDB. Follow the link on the screen to redeem your free offer. Do you find keeping up with the constantly evolving technologies a struggle? Do you want to bring your team up to speed on one of the latest technologies? This.Labs offers personalized training programs to suit your organizational needs, ensuring you and your company stay on the leading edge. Contact us today at hi@this.co to set up your complimentary needs assessment. And tune in every second Thursday of the month for React online meetups. This.'s online meetups are an amazing opportunity for developers and enthusiasts alike to engage with the global tech community no matter where they are in the world. Register to get your live link at reactjsmeetup.com. Today's session, we'll be covering databases made easy in React with GraphQL and FaunaDB. And on that note, Brecht, I will kick it over to you.
I'm Brecht. I work at FaunaDB, one of the sponsors, as you saw. Today I'm going to explain how to actually use the database to create a GraphQL endpoint in like 30 seconds. So this slide says it all. What you see on the left is the Fauna logo, on the right, GraphQL. So basically, in FaunaDB, you can import the GraphQL schema and you will get a GraphQL endpoint in 30 seconds. Not just any GraphQL point, and we will explain that further on. FaunaDB has quite some advantages, and these advantages also shine through in the GraphQL endpoint. So let's just get started. So the idea is to have a bit of an explanation about FaunaDB, because it's a database. Databases are very different kinds of databases, so we do have to explain a little bit about that. And then we'll just go into the dashboard, explain how to do it, just throw in the GraphQL schema and show you what it actually brings you, and we'll probably even get to plugging it in a small React application, and we'll show you the code and how to plug that in or how to do the authentication. Of course, when we do something live like this, we never know what goes wrong and we never know how far we will get. So I hope I get to the end. We will see. If there are any questions, don't hesitate to ask them. I prefer to have an interaction with the people. So feel free to ask questions while I'm speaking about something. So let's get started about FaunaDB. So what is it? First of all, why is FaunaDB actually talking to a JavaScript crowd? So there is one specific reason for that, and that is that FaunaDB is an API, and it's actually optimized to be accessed from either the frontend or the serverless functions. And why is that? Is just exactly because it's an API. What does that mean? It's not like a regular database where you would open a connection and you have to maintain that connection open. And you have a limited amount of connections. So you might see that would be a problem if many frontends would connect to that database directly. FaunaDB is different. It's really an API, so you're going to access it just by calling an API and sending a token along with it. So the amount of connections that you open, it's not a connection that persists, so that doesn't really matter. So you can connect with it from many frontends, many serverless functions. So we say this is actually connectionless. It's not so often that you see a database that behaves like that. And besides that, we have a security layer and something we call user-defined functions, which are part of that security layer. And of course, the tokens that you send to the API are part of it, which make it possible to actually access the database straight from the front end. And then finally, it's zero operations. What does that mean? You don't have to set up servers. You don't have to think about it. And if you're a front-ender, if I'm doing front-end in every case, I prefer to focus on user experience instead of setting up servers, defining how many shards I want in my database, or provision read operations. In FaunaDB, you just connect to the dashboard, you log in, and you say new database, and you can get started. But we'll see that, but since I will do it in this talk. So we're going to set up a full-blown GraphQL backend in 30 seconds after this short introduction to Fauna. So basically, who am I? Well, at daytime, I'm a developer advocate at FaunaDB. I didn't always work like that. I used to be just a developer. I was a full-stack developer. I worked in research. I worked in consultancy. I worked in small startups. Did analytics, front-end, back-end, databases, doesn't really matter. I did a lot of things. And I was actually following FaunaDB for 2 years already because I found the technology behind it extremely interesting. So why not join them if you find them that interesting, right? And at nighttime, I'm a musician. I sing and play guitar in quite some hard rock bands. So I'm not a live coder. I don't do this very often, but I already have the equipment to do it, so that's cool. Finally, before we go into the theory about what FaunaDB is, we're going to introduce sparkles. Why? Because I noticed that when we do this presentation, often people take all these things that you can do with FaunaDB for granted. And sparkles will actually serve to highlight things that are not very common in distributed databases. So we're really talking about distributed scalable databases. Every time you see this icon, it's something that a lot of databases don't offer, and we do. So it's just to highlight the things that make FaunaDB unique. So watch out for sparkles. So let's get started. Basically, what is FaunaDB? Well, the simplest way to describe it is that an indexed document database. What does a document mean? So data is just stored as enhanced JSON documents, as you can see there. So basically, these are just documents with references in that. You can have nested documents, you can have arrays in there, so it's just JSON, but you do have these references. So you either get the choice, you can make complex nested documents, or you can normalize your data and have flat documents and have relations between them. You can actually choose. So what is the indexed part? You can, in FaunaDB, index everything at whatever moment you want and however you want. So the indexes are extremely flexible, and you can make them afterwards, or you can make them before you actually start querying. So in this example, we might index on author because we want to get all entities by author. That's possible. Then we can say, okay, we want to get entities by author and hashtag. We just make another index that has 2 terms, no problem. Then we want to get entities by author and hashtag and greater than 100 and smaller than 100. That doesn't make sense. That should be 150 or something. So I have to change that. You can just do that, and you can even add multiple values. And Sparkles is there because that's quite unique. For distributed databases, these kind of indexes or queries are often very hard. And in FaunaDB, your indexes are essentially extremely flexible. Then there is what kind of database is FaunaDB? Well, it blends together things of relational databases, temporal databases, and graph databases. And of course, the document database, we already saw that. So what does the relational mean? Well, I highlighted it already. you have references in there, and you can actually follow those references. So you can actually model something like this with users' tweets, which we call tweets because they're Fauna tweets in our application, and hashtags. And we don't have to put these documents straight in this document. We can actually put the references there, and then we can write a join. We have again sparkles because joins are often not an option in scalable databases. That makes it very, very difficult to write applications that are stable and that keep your data consistent. Or with consistent, we mean that your data doesn't get messed up over time. And that is something that many databases don't provide. Then there's temporal. So every document, you can choose to have every document you can save versions over time of every document automatically by just saying, okay, I want versioning on this collection, and then FaunaDB would keep all old collections and make it efficient to access that. So you can basically say, let's do a query at a given timestamp as the time that that will query it as if the document had the values of that time. Something else we can do is just get all the events of a certain document. So for example, if we call this query, what we get is a stream of all the events that change that document. So we can see all the updates. That's also unique for FaunaDB. I think there's only one other database that does it. I know there are multiple now, but before it was only Datomic, and that's not a distributed database. It's quite an impressive database though. But it's also something very unique. And this is super useful if you want to, for example, sync your data with another system or you want live updates. Then finally, there's Graph. You don't have to understand this query yet because we didn't explain this yet. But what you can easily do is compose queries that follow references. So for example, here we start with the user. That returns a reference. We're going to put this in another query, which returns the friend of that user. And we can actually continue doing that, which makes it, that composability of our language makes it actually very easy to just follow references and make graph-like queries. Is it a graph database? Not entirely. So there are other things, more flexible graph-like queries that we don't support, but we do offer graph-like queries, which make it actually very, very, very nice to support GraphQL, because this is very similar to nested GraphQL queries in the sense that if you do such a complex GraphQL query where you're going to get skills, then you're going to put all profiles that are related to these skills in there. And for each profile, all the skills that are related to that profile and project. This is quite difficult in many GraphQL backends in the sense that this will create many queries. In our GraphQL, we can actually support this super easy. This translates one-to-one efficient Fauna query. So basically, we've already said it. We have two languages, the Fauna query language for very advanced queries, and for things that the GraphQL spec does not provide yet. So for example, temporality or authentication, we will do in FQL. But the GraphQL actually translates to FQL one-on-one. So it's very, very efficient. FaunaDB is also a distributed and multi-region database, and not only distributed, it's really multi-region. What does that mean for the end user? That basically means that wherever your client is, if you have a front end at a specific location, you will get the data from the closest location. So that means low latencies, which is, of course, pretty cool. And that can only be done if your database is multi-region. Besides of that, we also scale automatically. So all of these things will automatically scale up. All of these clusters will automatically scale up as the usage increases. The cool thing is actually you don't have to care about that. So I'm explaining you now that we're scalable and all these things scale behind your back, but you don't have to care about things that you do have to care about in other databases like sharding, provisioning, or servers. As far as you are concerned, the database is serverless. In that sense, it's serverless, in the sense that you don't have to worry about these things and you barely even see that they exist. They will just scale along for you. You don't have to worry about that, which is also quite unique. Why is that super unique? Well, we will explain how most databases do the scaling. So most databases will do the first or the second. That means you're going to provision a certain amount of read or write operations. And when you start using it at a certain moment, you will hit a certain plateau. And at that point, yeah, a lot of users that try to query your data or try to query your application will actually get cut off. So that's not what we're doing. Another approach often is to try to estimate the provisioning. That means that they're going to try to estimate how many reads or writes you will need depending on your usage. But that often backfires at the moment you have a really, really high peak suddenly of users, which can happen. Imagine you get featured in a certain article or you're writing an application for the elections, then you will see a peak. And in that case, you will have the same problem. That's how many databases work. Well, FaunaDB is unique in the sense that it's just seamless scaling. That was a combination of scaling and it's seamless. So it just seamless scales. It scales with the usage, and basically what you pay is exactly the usage. So it goes along, and what you will pay would be the usage minus the free tier. As was mentioned in the advertisement, we have a quite generous free tier. What does that mean? Well, you have like 100,000 read operations per day for free, which is, you can get quite far with that. You can write a complete application and develop it without even getting at 50,000 a week, so, or at a month. So that will get you quite far. Then finally, this is one of the major features of FaunaDB, but it's also the hardest to explain. Basically, FaunaDB is 100% ACID and is transactional. In simple words, what does that mean? You can't have really strange things that happen in your database with your data. So in other databases that don't have this, you might have failed uniqueness. So you try to get make sure that you can only have users register with the same name once. That will often fail in databases that are not consistent, so which this example shows. So two users registered with exactly the same name. Sometimes ordering just changes in these databases, in the sense, here, for example, what he actually said first was "thank you for serving our country," and then he said, "oh, I mean serving," because he clearly made a typo. If you change that order, well, it becomes completely unclear for the other user what happened. And this might become very, very complex if you have more advanced logic. And then finally, basically, it means read what you write. I won't explain this picture, that basically, well, I will explain it, but very simple. So basically, two users try to get gold from a chest in a game, and both of them see that there is still gold in there, but only one gets the gold. And why is that? Because one of these distributed servers is behind the other one, and one user is talking to one server and the other is to the other. That's too complex to explain now, so I wrote a complete article to explain all the issues that could happen and how this is actually solved by databases like FaunaDB. I also explain a little bit about other databases. So if you want to know more, I would search for this article, CSS tricks, consistent backends, and UX. So that will explain it way better than I can explain it now. But it's also something pretty unique. So distributed databases that support this can be counted on one hand. So for example, Spanner, FaunaDB, and Firestore support this. If you want relational distributed databases that support this, you only have Spanner and FaunaDB left. And on top of that, we have a quite unique algorithm that makes sure that this works. And that algorithm can get theoretical lower latencies. It also means that algorithm also provides us with the means to host this on any hardware we want, which is not the case for Spanner, for example. So that means we can deploy this cluster on AWS, on Google Cloud, on Azure, that really doesn't matter, which makes it possible to actually put clusters everywhere in the world in the long run. And then finally, it's good to mention it's validated by Jepson. Jepson is a person who basically breaks databases as a living. So if a database is validated by someone that is independently trying to break it, that's a good thing. So the final thing is cloud service and zero operations. I don't have to explain you that. We're just going to show it. So basically that means that you don't have to set up service. You just make an account and you get started. And that's exactly what we're going to do. So let's just make a database. Coding time. So dashboard.fauna.com. We'll just log in. And you can see from the moment I log in, I have multiple databases. So basically, you can make a lot of databases in FaunaDB. I can make another one. I don't know. Yeah, they can't contain spaces. Yes. If I go back to the DB overview, now I have another one. And the cool thing is you can actually have databases in databases. So that makes it easy to organize things. That makes it easy to make a database for a certain team in your application. And I actually use it to run different unit tests suites on a different databases so they can actually run in parallel, which is quite cool. So you don't have to make multiple accounts. You can make virtually as many databases as you want in your account. I'm going to delete this one. I don't like it. So we go to demos, and you see I've done a few demos, or I prepared a few demos already. So I'm going to make another one, demo GraphQL 7. Now you get this view, and this is your database view where you have collections, indexes, functions, the shell to actually test things, and the GraphQL Playground. This is where we're going directly because all the rest will actually be taken care of for you when you just use GraphQL. So basically you import the schema, and I saved the schema somewhere. And we just immediately get a GraphQL endpoint. Now, of course, it's quite useful that I first show the schema to you guys before we continue. So let's quickly do that. There we go. So this is how the schema looks. It's moderately complex. I try to do a bit more complex than a to-do application, but not too complex. So what we see there is an account with just an email. And the interesting thing is here uniqueness. So you can specify a kind of tag that says that this account can only have, that you can only create an account with the same email once, else it will throw an error. Then we have profiles, and this will be the bulk of our application, because if we look at our application, these are the profiles. So basically users, it's a kind of professional network where you can have users that have skills and projects. So that's what our profiles are. And you can see here that we define a name, an icon, which is just a string, and we have some predefined icons for the persons. They will be linked to an account, and there you can see the relation attribute. That relation attribute just indicates to FaunaDB that this will be actually a relation to account and actually helps FaunaDB to determine how things are linked together. It's not always necessary, but it's a good idea to do if there are many-to-many relations like here. So you have many skills that link to a profile. So we can put an array here. That's no problem. This is a many-to-many relation, the same for project. Then you have project skills, and finally the queries that we will use. So we will just get all profiles, which is easy. We will get accounts by email, and that's something we will ignore for now. So ignore that. That's for the authentication that we will see afterwards. And finally, skills by name. So this will allow us to actually get a skill by name. And from that skill, we can just get the profiles and continue like that. So and then there are mutations. So we have a register and a login mutation. That's also for authentication. We will explain it later. But what you can also already notice is that there is a resolver tag here. And that resolver tag we will explain at the moment we get to authentication. Okay, back to the dashboard. So we just imported the schema, and we now have this GraphQL Playground. What you will see is that we now have documentation and a schema. So here you can see what queries are provided and what mutations are provided. You can see that FaunaDB actually generated a lot of queries for you. So we only had to define a specific queries like get all profiles or get a skill by a name. And all the rest is actually provided for you. Besides of that, you also have the mutations to start creating things. So we're just first going to show the schema, and then we're going to use a mutation to actually create a few profiles to get started. In schema, you can actually see what kind of schema FaunaDB creates from the original schema, since it will add a lot of things to make a lot of more things possible. And if you ever want to just change the schema, you can update it or override it. So update will just update it, override it will just really delete your data and then insert a new schema. Okay, so what can we do with that now? Basically, we can just get started and start writing queries. I'm just going to see what I wanted to show exactly. And yeah, so we basically want to start off with a mutation. Let's just give it a name. Then we can automatically create a profile. Let's say, okay, the data in that profile is just going to be a name. And let's name him Christian Reichert the First. Actually mistyped. That doesn't really matter. Redshirt in that case. And let's give it an icon. So as I said, we had predefined icons. Person is just person 1, person 2 until person 10. So that will just define which icon you can see here in the application. So if we're going to execute that, I'm actually going to zoom in because I'm not sure whether you guys can actually read this. So if we execute this, we actually made a mistake. Oh yeah, I didn't return anything, which we still have to do here. So we also, after creating it, we're just going to return the ID. There we go. We created a profile. What you will see now in the collections is because we added the schema, FaunaDB has done a bunch of things for us. It created all the collections. So we mentioned this document based, and we can actually now see these collections, which are like tables here. And we can see that it created the document, which we just inserted via GraphQL. And besides of that, it also created a bunch of indexes, which we will see later. What is interesting to see is for the collections is that we have a profile projects and a profile skills. And although we didn't define this, this is because we have a many-to-many relation between profiles and projects. So that's how FaunaDB solves that behind your back. You don't have to worry about it. So how does it actually work? We can actually just start with adding projects in here as well. So let's say should be projects because there are multiple. And we can now say, okay, we want to create projects because we also have the option when we update a profile to actually connect a new project to that profile in case we want to edit things afterwards. And let's say we have a project called Awesome Rubber Computer. Okay. Let's hope this works. I actually don't need the commas. I always tend to type commas in GraphQL. And when we do this, we again get the results with the ID. And we can see actually that we created a second profile. We gave it the same name. That was a bit stupid of me, but what we will see now is that, okay, it looks exactly the same as the other one, but there will be a link here that connects this profile to a project. And we will also see that we just created this project with the name Awesome Rubber Computer. That's all done for you. And afterwards, what we can do, let's say, I want to actually make another user. And let's this time give it another name. Let's say Cynthia Murray MD. And let's give it another icon. And instead of creating a project, I already know that this exists, so I don't want to create another project. So we could actually link it to that project. And that's done by using the connect. And then instead of the name here, I'm going to drag this a bit there so you can actually see it better. Instead of the name there, you're going to just insert an ID. So I'll open a second dashboard to just get the ID. It'll be easier. We're going to connect it to a project, and we're going to connect it to this specific ID. Let's hope this works. And actually, we're going to do more. We're going to do at the same time create another project. I'm going to name that Fantastic Fresh at. Right. So now it will create a project and connect to the old project that we already have the ID from. And let's do one thing more and still hope that I have valid GraphQL here, that I didn't mess up. We're going to create skills at the same time. So let's say prologue. I have to put what's around this. And let's say I also know Java and FQL, which is a Fauna query language. Let's try. So this works. What did it do? So basically now we have a profile. We have Cynthia Murray with a new icon. We have another connection to a project, from the profile to the project. And it's actually the new project we saw. And it will also, you actually notice that we added two. There were these two appeared. And one is linking to the new project, one is linking to the old project that we provided the ID for. And we also see that there are 3 skills linked, and we can find the skills here. So that's all it takes to actually create our data. So let's go back here. I think that's most of the things that you want to do to actually just create things. What we can also show now is to actually update one. So for example, how just a second, because I'm actually lost in my files here. So yes, there we go. Basically, why I'm searching for files is because I never use GraphQL myself. So for me, it's always looking for the syntax again. So actually quite easy. So I don't know why I always forget, probably because I just never wrote a real complete project with it, which I will do now, actually pretty soon too, because I want this project that I'm showing you today. I want to actually roll it out so you have a really complex example project, because it still has to grow. It's not that complex yet. So imagine we want to update a profile. We would actually insert a specific ID. So let's get an ID of a specific profile. Let's say this one. That's Christian. No, let's update Murray, because else we don't know which one. So let's okay. Actually, no, we can just update this one. That's fine. So we're going to update this one. We're going to insert that one. Actually, you have now an updated name. Quite original, right? And we're going to say that it has another person ID, another icon, I mean, which is another name. In this case, person 3 is another icon. What we can do now then is say, okay, I actually didn't like the projects he had before. I'm missing a colon there. Actually, this is not necessary. It's we're just going to define that we're going to create a new project. So I want to add a new one. Let's call it Magnificent Circular Guitar. And I can't really type, you see. That doesn't really matter. So let's continue. And we're also going to disconnect the previous one. So here we need to disconnect another project. And which one did we define? I think this one was linked right there, right? I know the first one was actually linked to nothing. So we can't really disconnect this. So I will need the second one. This one was linked to a profile. And so now we have 3 links. We're going to disconnect this one from the old project he was linked to. Blip, blip, blip. And I think I did the same thing as always. That is, forget to define what to return. Projects is not defined. That's correct, because it's projects. Da-da-da, this worked. So now we still have 3, but you will actually notice that there's a new one, and it's actually linked to that new one. The other one is removed. Let's try to prove that, right? So what we're going to do is query, and then at least we can already show how querying works. I don't think we need brackets here, but so to keep it simple and see whether we have the right syntax, let's start with this. That doesn't look right. I made a mistake. Yeah, there we go. Now we can just say, okay, I want a name. What else? We had the icon, right? That works. Now we can say, I also want to see the profiles, and FaunaDB will automatically use the indexes that we created and the other collections to link all this data together. So that's pretty cool, right? So made a mistake again. Ah yeah, profiles. No, that's projects. Right. So now we can already see that the person we updated has one project linked to it. So we disconnected the other one, we added the new one, and we don't have to wait any longer. Ta-da, we are linked to the new project. And we can actually see that we can easily do very complex queries here. So there we go. Now we have all the skills as well. And as we saw, we added a few skills to the other one. What I will do now is show you a few other cool things that you can do with FaunaDB. So one thing that you can see here is that we can also add a TS, and TS stands for timestamp. It actually shows you the timestamp because FaunaDB is temporal. Everything is timestamped in FaunaDB. So you can actually get the timestamp back in every query. That's super easy. And another thing that we can do is actually ask for the... No, it's not something we can do. We can say, yeah, here. We can say we only want the first one. I have to put a colon here. We can only get the first one, or we can only get the second one. And yeah, then you can also say that you want to get the after. I think it's here. Yes. And before. What you will notice now is that we get a cursor back. And so basically this is the pagination. So you get pagination for free, which means that if we only got 2 items now, and we can actually just say, okay, now I want to get all the items from after this cursor. Now we get the last one, and now we get a before because we can go back in the other direction. This actually made it possible for me to easily implement these. So actually the data that you're seeing now is one of the other databases you saw. So we have more entities here. So you can actually go back, next, previous, and every time we just go to the next and the previous page. These are the ones I created as well for tests, so that's they don't have an icon, so that's why they're looking like that. Okay, that actually explains retrieving and after and before, and we can actually look how that looks. Actually, we need one more query. So one more query I will need is to support this. I actually don't have one like that. So you can actually search for an exact keyword. So for example, I get now all the profiles with Java. And how we can do that is by using the other function. So if we go back at our schema, which I will show you here, we provided skills by name. So we will now use that since FaunaDB generated all the collection and indexes to actually support that. So what we can enter here is an extra parameter, and this can be, for example, Java. And what we will return is just data ID, syntax error somewhere. What did you do wrong now, Brecht? Oh yeah, you don't need colons. I always type colons. It looks too much like JSON for me. So as we defined before, there was actually one profile, the last one, that had a skill Java. So we can actually now search for Prolog, Java, and FQL out of the box. Oops, wrong tab. Here. So if you FQL, we get the same one. Well, it's another skill, of course. Now we're searching for skill, but that doesn't really matter because it's quite easy to get the profiles as well, right? So let's say we actually don't care for the ID of the skill because what we really want is a profile. Then we just do this. There we go. Whatever we type in, Cynthia was the only one with skills, so we'd always find her. And if we search something that doesn't exist, we of course get an empty list. Now let's show how that looks like in code. And I think I need to zoom out a little bit. So this is basically the code for our GraphQL application. And basically we have something called Fauna query. And this is exactly the same query we used before. And we say, okay, we will paginate per pages of size 6 here. And we will provide a cursor. And that cursor is basically a cursor that is, we throw it back to the component that calls this get profile. And it will, when it calls it, will provide the previous before, the previous after. And that makes it possible for us to just throw in this query and get this behavior. That doesn't work because there is only one page for Java. It doesn't really matter whether we filter or not, we can still paginate on there as well. So that is simple get profiles, and the get profiles by skill that we entered here is actually just the same. By the way, you could use Apollo to make these queries better. I just used strings here. That's not common practice, but I wanted to get this done quickly. And we'll probably change this in the future. So get profiles by skill is exactly the same. We pass in the cursor as well. Only now we also provide a name. And instead of getting profiles directly, we first get skills, so then we have to get the profiles. But exactly the same here as what we can find here. So it's just a copy paste. And then afterwards, we can just get the specific profiles out of there. That's all we have to do. Now, the question that remains is, okay, but how do you, is this secure? Why can you access the database right from straight from the front end? The way we do that is by using the security layer from FaunaDB. So let's actually go to this specific database. Actually, I'm not sure which one I use, but let's take a look. Is it 6? Let's go to the first page, log in. That looks like this one, updated, and it doesn't have an icon. So if we would, let's just be sure. Right, so I prepared this one so we don't have to populate the data all over again. Yes, that's the one, and now it has an icon. So how do we actually log in? That will all be in the dashboard, so let's remove my code window. The first thing we can actually do, actually we do need the code window. Let's quickly grab it first. The first thing we need to do is provide a token. So one thing you will notice if we go to Fauna queries is that here this specific part is just fetching the GraphQL API. So this is the URL from Fauna. And it's always providing a secret. And basically that secret is going to be initially, at first, get from a environment variable, right? And we will actually notice that when we log in, we replace that secret, but we will come back to that. But hold that in mind. So we start with a bootstrap token, and then when we log in, we actually replace the secret that we will use for further queries. This is the 6 database. I'm going to close this one. Let's start off with just removing that token. So imagine there is no token there. I'll just restart my front end. Basically, I don't get in. And this will also not work, right? We can now start off just exemplary, just to make you understand how the rules work, is by creating a role. And let's just say, I actually created this already, it's in there, but I want to create it with you. Let's say we want to create a really, really insecure role, but that might be a use case. That's not that it's insecure, but imagine you want to build an application and everything in your application is just public. That can be possible. So in that case, we would just say everything in here should be accessible. So these are all the collections that the GraphQL endpoint made for you. And we're just going to say, okay, this can all be read. Going to add all the indexes. There are quite a lot. I'm going to do the same. Going to save this role. And what can we do with the role, since now we just said this role gives you access to all these things. What we can do with that now is say, I want to create a role, a key, I mean, and I want this key to actually have that role that we just created. And let's say we can give it a name. We now get a secret, and if we enter that secret here, we start the front end. And remember, we didn't get access to anything just before. Well, now we don't even have to log in. We just get access to everything. I actually did a check to make sure that we try to query from the beginning and else revert to login. So that's why this is working. So in this case, we can get access to everything. In some cases, that might be a good idea to put everything public, but in this case, I don't want it. I want to have a login and register. What we want to do then is actually make a different kind of role. And I actually already created this as well, but let's do it again. Is a role that says the only thing you can do from the moment you actually are not registered is call two functions. And these are login and register. Let's save that role. Which is this one. Let's create a key again. And let's say call functions. Now if we enter this key, yes, and then restart our front end again. We don't get access by default. That's what we want. But what we do get is we get access to call login functions. Okay. And now, of course, we're missing a big part here. What are these login functions? So if we turn back, and I already highlighted it at the beginning, is that we had these things here in our schema. So these things where you put a mutation in there and add a tag resolver, that's to indicate that you're going to add functionality to GraphQL, which is not provided by our GraphQL layer by default. You're going to add custom behavior. And since logging in and registering is not part of standard GraphQL, this is basically what you have to do there. So there's an escape hatch for custom behavior that we don't provide out of the box. So what does this do? If we go to our database, and we actually have to look at demo GraphQL 7, the new one we created, because this one, I already did stuff to it. What it actually did is it created two functions, login and register. And what you will see here is Fauna query language. So you can always write custom things on top of the GraphQL in just the Fauna query language. And a function is a bit like a stored procedure for people that come from SQL or from a traditional database. And that's something that we can call in plain GraphQL now. So we're back at the database we created together. So we didn't write functions yet. The functions are let's go back here. Functions are defined by just importing the GraphQL schema, but now they will just abort. So they are not filled in yet. That's for you to do. So what we can do now in the GraphQL is to just write, let's see whether I can get this right. Yeah, so it's just mutation. Let's say call login. The name doesn't really matter. And you can see now that we have a login mutation. What we can provide there is an email. Let's say test@test.com and a password. Just test. And as you see now, we get an error because it was not implemented yet. So basically, we have to implement that then. And the login part is pretty easy. So let's do that. See. Yeah. This function can run with server privileges. That's what we say here. And the function I pasted in here, so that's pure SQL. I pasted it in because that's not the core of this course. But basically what we're doing here is we're writing a function that takes an email and a password. And then we're going to, if we take this part out, get users, no, actually accounts, get accounts by email and provide that get with the email parameter we provided to the function. So we're going to get here a specific account. And on that account, we're going to call login. And login is actually the main focus here. Login is a function that we provide, which allows you to do password-based login. So you can provide a password to login. And when you do that, and there is an account with that password, you will get a token back. And that token will be exactly what we can use to do our queries. And you can actually see that when we go back to the code. And here, Fauna queries. Once we log in, we get from login a specific result, and in that result is a secret. And we're going to actually set that secret, and that is going to be the next secret we use. What we didn't explain yet is how do we actually make sure that an account has a secret? Well, basically, that's the next part, and that's the register part. And as you saw until now, we just provided data. But what we can also do, oh, that's the wrong one. And I'm going a bit faster because we're almost out of time. What we can also do is actually in SQL create the same collection. And this is a part that is not provided by GraphQL because it's not really in the standard of GraphQL. So that you can do in pure SQL by using functions is to create a specific account. And we're going to use a specific field in here. So this is everything we've done until now. We added data. All these things we did through GraphQL come in the data field. But credentials and password is a specific field that is going to be encrypted and is never going to be returned. So if we save this function, I want to just refresh this. And we're going also to give it the server functionality. Just going to check whether I actually did. No, I didn't save this function. Whoop. Now we actually can go back here, and we have to start with call register, of course, because else we won't have a user. And I have to provide something in the return field again. I keep on doing that, I think. And actually, I clicked it twice, so you immediately see that our uniqueness that we use on the GraphQL actually works. So we can't make two instances with the same email. And we actually created an account now. So we can see that here. And that is by going through this function. And by going through that, we actually set the password as well. And that means that we can actually go back to our, I'll just type it, call login. And I don't know if I have to provide that on login. Mutation. Yeah, I thought so. I don't have to provide the result there. And the result is a key. And if we're going to provide this key, so we might actually do that if I provide this key into the, if I use this key to call the GraphQL, I will actually get the permissions of this specific entity. So there is one thing missing. We now have a key for an account, but how do we define what permissions that account has? And for that, let's go back to the database I prepared. So where were we? We had access, right? We logged in, we have access. That's database I prepared. So we have access. And how come do we have access? Well, because we logged in with an account. And if we're going to look at roles, then we actually see, yes, this one is the one I prepared, is that we have a similar read role where everything is readable. And I should actually limit this more. I don't want them to read accounts, for example. So I can do very complex things here. I can even write a function for that read. I can say only this specific person can read, but that's not the core. So let's ignore that. But what I did here is not only provide privileges, I also provide a membership. And basically, we set everyone in account, and we did projects as an example here as well. Every entity that is in account will have access. So basically, let's open this again. A small bug we have to fix. Yes. So if I remove accounts now, because this role is giving access to my accounts, and we log in again, log in, all I won't get access because I have an account token now. Why? Because we logged in and we replaced our secret. What comes out of the login is an account token. So we don't have access. The only thing we have to do is say, okay, the role with all these read access does have access to accounts. And now we have written a complete login flow actually to get your GraphQL started and bootstrapped. So did I save that? Yeah, I did. So if we do this again, right? And basically we're done. So we wrote a complete GraphQL. We had the UI, of course, already because the UI would be a bit too complex to get started. If there is anyone that is watching live and has any questions, I'm very welcome to answer them. Something that might be useful to see is some slides I prepared to, in case we had time. So what is actually cool about the GraphQL we just created is that Many GraphQL resolvers will just create a lot of calls to the database. So that's all the little birds here that fly to the database. So by creating GraphQL, we actually replaced REST. It does a lot of queries to the REST API if you write it like that. But we replace it with something that only requires one call from the frontend, but now we have a lot of calls to the database, which is also not ideal. Well, in FaunaDB, you don't have to do things like that, and these things are actually called the N+1 problem, which is often resolved by caching. In FaunaDB, it's only one query. So the whole thing we have here, the whole example with all these queries that go to the database, in the case of FaunaDB, that's only one query, and that's possible because we offer relations and have a very, very composable SQL query language. So that was it. I hope you enjoyed it. And keep looking out for the example, because this example is going to be finished and is going to be provided completely on GitHub. In the meantime, there is also, if you're interested in the Fauna query language and want to get started, I would say go to this article. We wrote a complete example that re-implements the basic features of Twitter with Fauna query language. So that's basically what it does. So complete Twitter.